Hello everyone, and welcome back to where we left off last time. So last time we created this sample class. It's very simple, it just has the pass keyword. But really what we're going to have in classes are attributes and methods. Attributes are characteristics of an object. Methods are operations we can perform on the object. So for example, what we will be doing is creating a class called dog. And an attribute of a dog may be the dog's breed or the dog's pet name. While a method of a dog can be something like the bark method, which will return a sound. We can say print woof woof, something of that nature. So let's start off by learning about attributes. So I will make this class be dog. And then let's change sample to be dog here. And let's say instead of lowercase x, we'll call this my dog, kind of like the same way we created something called my list. And then let's check the type of my dog. So we'll save this, run python notes.py, and here I can see class main.dog. So far, so good. So what we need to do is start off with attributes. The syntax for creating an attribute is self.the attribute name equals something. But there's a special method. So whenever you have a class, what you're going to be doing is defining methods inside that class. And the methods look like functions inside of a class. So we start off with the def keyword, and then a special method has a set of underscores surrounding its name. So we say underscore underscore init underscore underscore, then we pass in self, and then we can have a colon here, and here I will just put in pass. So this is the most basic special method you can have, the init method, and that stands for initialization. And this self keyword is always necessary. Basically what the self keyword here does is it tells that this method refers to itself being the actual class object. So if we save this and run it, we shouldn't see anything else different pop up. So we still have class dog. What we're going to do now is inside this initialization method, this init method, remember has two sets of underscores surrounding it, defining it as a special method. What we do is we add more attributes. So for instance, let's add in breed. So dogs can have a breed, and then what we do here is we have the syntax that looks like this. We say self.breed is equal to breed. And this is where it can get a little bit confusing, so what we will do is run this, and we should expect an error to pop up. And it will say init missing one required positional argument, breed, which now means whenever I create an instance of a dog class, I require breed as an argument. So here we say dog, let's provide it a breed. So we will say create a dog with the breed, and we'll pass in a string called lab. We save this, run this again, and now I see I have class main dog. So what we're going to do now is instead of printing the type of my dog, since we know now that it's always going to be a dog class, I'm going to say print my dog dot breed. And then if I run this, notice I get back out lab. And also note that I don't have closed parentheses around breed. I don't have something like this, and that's because it's an attribute. It's not a method. I don't want to call it to action. I just want to report back what that attribute is. So let's break this all down one more time. We have that init method, and it's called automatically right after the object has been created. So once we initialize the object, we actually call this method automatically. And then each attribute in a class definition begins with a reference to the instance object. And that, by convention, is this self keyword, which is basically saying refer to this particular instance of this object. The breed here is the argument, and the value is passed during the instantiation or initialization of the class itself, where we say breed is equal to lab here. And now we've created an instance of the dog class. So let's create one other instance. We can say other dog is equal to dog, breed equal to, and we'll say husky. Save that, and then let's print out the other dog dot breed. Save it, we run this, and we see we have lab and husky come out. Now let's practice adding one more attribute. So I'm going to get rid of this other dog, and we'll just stick with my dog. Get rid of this other dog as well. And this dog, or dogs in general, won't just have breeds. Let's say they have names. This is kind of like a pet name. So what we do for every attribute, what we do is we say self dot, and then the name of that attribute is equal to name. And again, what this is doing is it's saying self, which refers to this dog, dot name, so the attribute name for this dog is equal to name, which is going to be the name here. So again, this name on the right-hand side of the equal sign refers to the input name. This self.name is kind of assigning the .name to the initialization of that dog. So now, if I save this and try to run this, I will get an error because I need to provide a name. So it says init is missing one required positional argument, name. So let's give it a name, and we'll name this Sammy, which is my real dog. Now if I run this, I get lab, and I can also print out my dog's name. So we'll say my dog dot name. Save this, run it, and now I see lab and Sammy. And usually when creating an actual instance of an object, you won't specify breed is equal to something, name is equal to something, unless you want to really specifically target that, so you come back to your code and read, oh yeah, lab stands for breed, Sammy stands for name. If you're really comfortable with an object and you tend to use it a lot, what you'll end up seeing is something more along the lines of this, where you just say lab and Sammy. They have to go in the correct order to be assigned to breed and name, but you'll most likely see an instantiation of an object look like that. And if I run this code, I get back the same thing, lab and Sammy. All right, that's the very basics of attributes. Again, if you have any questions, feel free to post to the Q&A forums, but I also recommend that you check out the Part 2 Object-Oriented Programming.py, which has a lot of notes and a lot of explanatory text for everything we're doing here. Next, I want to talk about class object attributes. So class object attributes are always the same for any instance of the class. So for example, for a particular dog, you may have a different breed or you may have a different name. However, all dogs are mammals. Regardless of their breed or regardless of their name, they're always going to be a mammal. What we can do in that case is add what's known as a class object attribute. And a class object attribute goes outside of any of these special methods or normal methods at the very top. So we'll say class object attribute to point it out. And then I can say something like species is equal to mammal. And if you study biology, you know that species doesn't actually relate to mammal. It's more of the class of Mammalia, I believe. But cut me some slack here because I can't really use this class keyword. So we'll just say species is equal to mammal, regardless if that's biologically correct. All right, so now I'm going to save this. I run this again, and I see lab Sammy. So note, I haven't actually defined species is equal to mammal here. That's taken as a class object attribute to be true, regardless of what kind of dog I have. So whether it's a husky, a lab, regardless of what his name is, if I say print my dog dot species, I will get back mammal, which makes sense. Regardless of whatever I want the breed or name to be, this class object attribute will always be true to be equal to mammal. Okay, now let's move on to actual methods. Methods are functions defined inside the body of a class. They are used to perform operations with the attributes of our objects, and methods are essential in encapsulation concepts of the object-oriented programming paradigm. And this is essential in dividing the responsibilities in programming, especially in large applications. And basically, methods are kind of the whole point of why you would want to even create your own object. So let's kind of delete all this and show you some more examples of how to create a class, not just with attributes, but with methods themselves. So I will create a class, and I will call it circle class. And I'm going to give it a class object attribute where pi is equal to 3.14. Now there are ways to call pi from the math library in Python, but we'll just ignore that for now. We'll say that regardless of what kind of circle you have, the pi, that special number, is always going to be equal to 3.14, or estimated. Next, I'm going to create my initialization special method. You're always going to have this. So we'll say underscore underscore init, so initialize, with self, and every circle, in order to be defined, needs a radius. So we'll say radius. And if we want to be instantiated with a default parameter, just like we could with a normal function, I can say equals 1, which means if I don't provide a radius, I will provide the default value of 1. And since I have radius there, I need to say self.radius. So self.radius, which means this circle.radius, is going to be equal to the input radius. Now let's create an instance of circle. We'll call it myC is equal to circle, close parentheses, and then I'm going to print myC.radius. Save that, run our notes, and we see here my radius is 1. Perfect. Okay, so let's show an example of a method. And remember that methods are functions defined inside the body of a class. And basically they're going to allow us to perform actions based off the attributes of the object. So let's create a method that calculates the area of a circle. We'll call it def area, and we need to pass in the keyword self, S-E-L-F. And that basically tells this method area that it's not just some free-floating function inside of this class, it's actually a method of that class, and that's what the self keyword is doing. Then I'm going to calculate the area. And remember that the area of a circle is just its radius squared, so radius times radius, times pi. But here's an issue if I just type this out. This is a common mistake that beginners make. They type radius times pi, and they think they're good to go. But the problem here is, what radius are you talking about? Are you talking about this circle's radius or some variable called radius? The way to make sure that you know you're talking about this circle's own radius when you actually instantiate it is you need to say self.radius. And that tells this method, hey, look at the object's current radius and call it self.radius. And I need to do the same thing here. And then since pi is an object level attribute, what I can do is say circle.pi. And now if I save that, let's create a circle, myC, with the radius equal to 3. If I save this, run this, I get back out as my output 3, which makes sense. Now let's see what happens if I call area, and let's call area with no open and close parentheses, just area like this, and see what happens. I hit enter, and I get an interesting line of output. I get that I have a bound method, circle.area, of main circle object at this kind of sequence of letters and numbers. What this actually means is this. If I just call .area, that is a method bound to the circle class. And it's a particular instance of the circle class object located at this position in my computer's memory. If I actually want to execute this method, I need to, just like I would for a function, have a set of open and close parentheses on it. Then when I run this code, python notes.py, I see here that my area is 28.26, or estimated to be, given that we're using 3.14 as our value of pi. Now let's imagine that I want to have a method that allows me to reset the radius. So there's two ways you can change attributes of a class in Python. One way is to just call it directly off the object itself. So we can say myC.radius is now equal to, we'll put in 100 to make it really obvious. And then if I call myC.area, we'll get a different answer. So if I run Python notes this time, I get 31,400 because I redefined the radius. Sometimes you actually just want to have a method in order to redefine something like that so that it's really clear. So let's make a very simple method that says set radius. It'll take in self, and then it will take in some new parameter, which will be something like new r. And then I will grab my current radius, which is self.radius, and set it equal to new r. And note that I'm not returning anything. And that's okay. Not all object methods need to return something. Some object methods just affect the object in place. So now, instead of saying myC equals, or myC.radius is equal to 100, what I can do is say myC.setRadius, and then pass in that new r value, 100. And this, well, just to show that this is working, let's pass in something like 999. So when I run this, I get some huge number here. So that's one way you can create methods that reset object attributes. It's sometimes more common to see it the way we first saw it, with myC.radius is equal to something else. Sometimes, depending if you have a really large file or you work with people that you really want to make sure they're doing things correctly, you set it to a particular method. It's really up to you. That's more of a programming choice. Programming style choice, that is. All right, so far we've covered methods and attributes. In the next section, we're going to be covering inheritance of different objects, and then we'll discuss some special methods. Thanks everyone, and I'll see you at the next lecture. If you have any questions, feel free to post to the Q&A forums, and I'm happy to help you out.